Now beyond the arithmetic operators, now let us come down to the unary operators. Now unary operators are so called because in this case there is only one operand. As in case of we had seen plus, minus, divide, we had two operands, whereas in case of unary operators there is only one operand. So the various operators that we have is the unary negative, we have the unary minus, unary plus, the post increment, pre increment, post decrement and pre decrement. So these operators we'll see in a altogether different lecture, and we'll just focus on these three operators in this lecture. Now unary positive is simply assignment of a positive to a number. So as I say, byte a is equal to 10, and if I put a positive before this, so this becomes plus 10. So even if I don't put this plus, the number still remains to be plus. So the putting of a unary plus does not impact the value or the character of the value. However, there is a small thing to be kept in mind. In case I say byte b is equal to plus a, so this will generate an error, as this leads to an operation which cannot be performed below an int. So after this plus appended to a variable say a, this result will become int, so we cannot store this in a byte. So this is the problem that we are having here. Either b needs to be int, or we need to convert the result into byte. So this is the only thing worth remembering here, is any operation, any simple even assignment of a positive to a number will lead to a result which is int. So we can print this. So b will come out to be 10. As you can see, b comes out to be 10. Similarly, the unary negative means that we multiply the number by minus 1. So in a way this b will now come out to be minus 10. So in a way this is equivalent to unary of the number plus 1. So we'll just see what unary negative of a number is. So this is calculated as this for a int number, and for a floating point number, if I say float a b is equal to 4.44 f and have a minus, and then float c is equal to minus of ab, simply reverses the sign of this. If it is minus 4.44, it will become plus 4.44 and nothing more. But for an integer, this negative means it will calculate the unary of the number negative and then add 1 to it. So for a floating, it is simply reversing the sign of the value. So in simple words, we can say if a is 10, minus of a will become minus 10, and if a is minus 10, minus of a will become 10. So in case I have a which is minus 10, so minus of a will become plus 10. As you can see, b now comes out to be plus 10, and similarly we can see what comes out to be for c. It is 4.44. So in case there is a negative sign, only difference is in the internal implementation of the operator. The answer will come out to be exactly same. The minus turns into plus, and the plus comes out to be minus. And the last of the operators is the unary negative. Let's see how it works out in bits. Suppose we say int a is equal to 6. So let us represent, or I'll take this as a byte value. These are 24 zeros, and these are the last 8. You can see 0, 0. I have 4 plus 2, so I'll have 0, 1, 1, 3, 4, 5, 6, 7, 8, and rest 24, they are all zeros. So these are the, we'll just concentrate on the last 8 bits. So unary of A will mean, so I'll just say this is white. So we can see the result much more effectively. If I say this is white, then unary of a byte number will become, every bit will change, 0 will become 1, become this. So this is unary of A, and let us see what value this number is. As we have already seen, for a negative number we need to calculate the 2's complement. So first we'll calculate the 1's complement, change every number to the reverse, 3, 4, 5, 0 to 1, 1 to 0, then add 1 to the number. So this is 1, 1, 1 and 5, 0. So this is what is unary of A. So this comes out to be 1 plus 2, 3, 3 plus 4, 7. And because there was a 1 in the extreme left, so unary of A comes out to be minus 7. So there is a shortcut to calculate in case we have A and we need to calculate unary of A. So this comes out to be equal to minus A minus 1. So as you can see, A is 6, minus 1, result comes out to be equal to minus 7, which is exactly what we are getting. So instead of calculating through bits, you can also directly calculate it as minus A minus 1. So, or otherwise, as we have just seen, unary of a number means you change every bit to the reverse. So this represents unary of A, and the value we can calculate through minus A minus 1, and we can just check out. So I will say int A is equal to 6, and we'll print out unary of A. So this comes out to be minus 7. So this is how this operator works, and all unary operators, they are applicable to a single operand. So that is why they are called as unary operators.